Hey guys, so this is the beginning to an Algebra 1 course following the New York State Algebra 1 Regents. Algebra is a branch of math that uses symbols to represent unknown numbers. It allows us to find patterns, solve problems involving unknown values, and write models in which include graphs and some statistics. Math is made up of these different branches that each focus on different things. You've already studied arithmetic, which is the study of basic number operations like addition, subtraction, multiplication, and division. Later on in your career, you'll also learn geometry, possibly next year, depending on your school, which is the study of shapes and angles. So, to get started, in algebra, we work with expressions, which are the combinations of numbers, variables, and operations. For example, in the expression 5x plus 1, the number 5 is called the coefficient, x is the variable, and 1 is the constant. To recap, a coefficient is the number in front of the variable. Operation is addition, subtraction, multiplication, division. It's the sign, what action you're doing. Variable is the unknown, defined as a letter usually, and then maybe this defined as a symbol. And the constant is a number without a variable attached. So, let's begin by learning how to simplify expressions by combining like terms. Like terms have the same variable and are raised to the same power. So we have 4x minus 2 plus 6 minus x. Here you could see that both of them have the same variable. And because of this, I'm able to combine like terms. So what I can do is use the commutative property, which allows for me to place them in locations next to each other to make this easier for me, and place them like so. And also flip around these two terms because they are also like terms, since they both are constants and have no variables attached to them. So I just put them like so. And now I just combine like terms. 4x minus x is 3x. So when there's an x by itself, that automatically means that there is a 1 in front of it. And you could just easily subtract like that. Don't be afraid of there being no number in front of the variable. That just means automatically you assume there's a 1. Okay, so now coming to this expression. 6 minus 2, that is 4. And that is our simplest expression. Another simpler example is something just like this, 2x plus 3x. So you see they have the same variable. So that means I'm able to just add them like this, like so, and get 5x. Anyways, guys, I rewrote this because my handwriting is really bad, and honestly, I don't want you guys suffering. So, yeah. Alright, so here we have another expression. It's a little bit unique. It's 3 parentheses x plus 1. Now, can you guess what it means? Well, it means that it is being multiplied. So, what do we do in this situation? Well, what we do is we use the distributive property. The distributive property means that we multiply the number outside the parentheses to each term inside. So in this case, we distribute here and we get 3x, and we also distribute here and we get 3, because 3 times x is 3x. And 3 times 1 is 3. Alright, so let's go over how multiplication can be seen. So, we have 3 times x, 3x, 3 parentheses x, 3x, x. Now, heads up on this one. In algebra, this sign is gone. We will not be using that standard multiplication sign anymore. It does not exist because the most common variables are x, y, and z, specifically x. So we will 100% not be seeing that multiplication sign anymore in algebra because it is just too confusing with the variables. Anyways, moving on. Let's do another example of this newly found distributive property. So we could do 5x times 3 plus 9x. So 5x times 3 is 15x, and 5x times 9x is actually 45x squared. The reason being is because when you multiply x by x, you get x squared. Taught you this yet, but when you have x to the x like this, that means that it's x to the first. And if you have another one of these, the rule is that you add these powers. You guys don't know what these powers are yet, but we will go over them soon. So, say we have something like x to the second times x to the first. It would become x to the 2 plus 1, or x cubed. So just letting you guys know, first to the first is 1, squared is 2, and cubed is 3. Those are very common terms. Oops, I don't know why I removed it, but x to the first, x to the second, x to the third. So it's not x to the third, it's x cubed. It's not x to the second, it's x squared. So, yep. So working with these numbers, we actually have to define two different types of numbers. So we have rational numbers, which are basically the normal numbers on this number line that you see. So 0, 1, 2, dot, dot, dot. That means going to infinity. -1, -2, dot, 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 going to negative infinity. And basically, a rational number is any number that can be written as a fraction. So, something like 0.333, repeating that little sign means repeating, can be turned into a fraction, which is 1/3. Same thing with 0.666, repeating becomes 2/3. Anyways, irrational numbers are numbers that can't be written as a fraction, and its decimal goes on forever without repeating. So something like pi, which is approximately 3.14159265358, you get the gist of it, guys. Goes on forever. Same thing with e. E, which is about 2.71828, I'm pretty sure. And same thing with square roots, which will go into depth as well. This is about 1.41. So these are irrational. And these ones we don't work with as much in this course. Rational is more where it's at because it has real world applications, etc. So to recap, a rational number is any number that can be written as a fraction, even if it's repeating, as long as it can be written as a fraction. And a irrational number is a number that can't be written as a fraction. So, moving on, we have to, when solving these expressions that we're talking about, so like 4 plus 3 times 7 minus 4 plus 2 minus 5, how do we solve them? You might say, oh, we go from left to right, like reading. 7 times 7 minus 4 plus 2 minus 5. But that is wrong. We follow something called PEMDAS, which stands for parentheses, exponent, multiplication, division, addition, subtraction. This is the order that we do our problems in. So let's take a look at this expression, the one that I just made. So we don't have any parentheses. We don't have any exponents, which is these. But we do have multiplication. So let's bring this down. Or actually, it's fine. So we do this first. Let me change the color. So 4 plus 2 times 7 is 21. Minus 4 plus 2 minus 5. So, yep, we did multiplication. Now, once we do this, we go all the way back to the p again. We don't have parentheses, we don't have an exponent, we don't have multiplication, no division. We do have addition, however, and subtraction. So, these are the last two, so we really don't need to look for anything else because we don't have any of the first four. So let's just do it now. So 25. I like doing it like this personally. Negative 4 plus 2 is negative 2 minus 5. 25 minus 7, 18. The reason why I have these little carets is because it's easier to visualize just two numbers being added instead of looking at the entire expression and being overwhelmed. So another thing about this is both multiplication and division, they're paired. So these both go from left to right. Say we have an expression like 16 divided by 4 times 3. We would do this first, which would become 4, and then we would multiply by 3, which would get us 12. So let's look at this complex expression. 5 plus 3 squared minus 1 times 2. So for this, it is okay for me to be using this multiplication system because of the fact that there are no variables. So PEMDAS, let's refer to PEMDAS. So do we have parentheses? Yep. Let's do it first. So what is inside the parentheses? So we have a exponent. So the exponent basically means that you multiply the number here that amount of times. So say we have 3 squared, which is 3 to the second. That equals 3 times 3. Say we have 3 cubed. That equals 3 times 3 times 3. So 3 times 3 is 9 minus 1 times 2. So we still have the parentheses. So we do 5 plus 8. And we still have these parentheses, but there's nothing to evaluate in them anymore. So we can just make it into just the normal number without the parentheses, which is 8. And we now refer back to PEMDAS. What is next? Multiplication. So we do 5 plus 8 times 2, which is 16. And 5 plus 16 is 21. So let's refer back to these variables. So say we have something like 4x plus 2 equals 5x plus 1. So when evaluating two expressions that equal each other, we want to get the variable by itself. So what we want to do is subtract over 4x from each side, and it becomes 2 equals x plus 1 because these cancel out, and 5x minus 4x is x. The reason why we're able to subtract terms is because these terms, as you can see, cancel out. Plus 4x minus 4x is equal to 0. So in reality, it's 0 plus 2. However, I'm just not going to write that because 0 plus 2 is 2. And another reason why we're able to subtract these terms from both sides is because they are set equal to each other. Anyways, so now we have 2 equals x plus 1, and these are like terms as well. They are both constants, so I can just subtract over 1, and it becomes x equals 1. Because these cancel out, they're both constants. And I forgot to mention, but the reason, a third reason that we're able to subtract them is because they are variables. I can't just subtract 2. It's because they're variables and they both have the same variable with the same power or exponent. So in algebra, an important part is the real world applications. So let me give you this example. We have this little mini word problem. So how would we write the sum of a number and 9? So the sum of a number, we don't know. So we can just make it any variable, x, y, z, whatever you want. I'll be using the most common one, x, and 9. And the reason why I'm using this sign is because there is sum here. How I got 9 is this, and a number is this. A number is the unknown. Another mini word problem we could have is 6 less than twice a number. So twice a number is, so 6 less is minus 6. But minus 6 what? 6 less than twice a number that we don't know. So twice is this. It's subtraction because it says less. The constant is 6 because it's less than twice a number. And a number is the variable that we do not know. Understanding how to move between words and algebraic expressions is kind of the main topic of algebra for the Regents, and it helps for us to set up these equations and be able to solve these real-world problems. Algebra is probably the branch of math that has the most applications to real life. And as we begin our study of algebra, remember that every skill that you learn builds a strong foundation for every other math class that follows. I'll also be doing tutorials on things such as AP classes that are STEM based, such as calculus, chemistry, physics, etc. Um, it does take time to make this content, but let me know what you guys would like to see next. Obviously, I will be still continuing regularly with this series. I hope to post at least every 2 days, and yep, this should 100% prepare you guys for the regions. Anyways, have a good one, and we learned a lot today.